welcome to PLAR Science. So we're into the last term of WASA, so it's term 2B. Actually, it's not the last term, it's the second last term because we do have term 3, but the last term for radio Zoom timetable. So term 2B runs for 9 weeks, and we started on Monday, April 15th, and it will end for students June 13th, which is a Thursday, 2024. The Friday, June 14th, would be the time when students can write the test. So 9 weeks altogether. So you can see that there wasn't a break in between week 9. So you can see on the timetable that you have for this year, week 9 was from April 9th to the 12th. And then we're right on to week 1, which started on the 15th. Okay, the other terms we've had a break, which was an admin week. So at the end of this week, and I'll keep you up to date on that, WASA will have 2 student draws. So we have all the names of students who earned a credit, and we have the names of all the students who submitted work. So for those students who earned a credit, their names will go for the draw for the Dell laptop, and then for students who submitted work, their names will go for the iPad mini. And this will be happening for term 2B as well. So be sure to submit your work to your teacher to be entered into the draw, and students that are working on more than one course will have their names entered for each subject that they submit work for. For the term 2B radio Zoom timetable, as you can see, we start at 10 a.m. with John doing the NBV3E, then at 11, MEL3E with Kobe, MAP4C also with Kobe, then we have LNO AO with Ira, then ENG4C with Doug, PLAR Science Mondays and Wednesdays except for this week, and then Tuesdays and Thursdays for PLAR Math. Then we have John for NBE3C, Jillian OLC40, and then we have the co-op for DC030 with Katie. So just remember to make contact with your teacher. Teachers will be contacting students, or if they have contacted them already, check your request messages if you have Facebook, or if you have provided your Facebook profile for us, then more than likely we will try to contact you there on Messenger. So all students are welcome to join the radio Zoom classes. So let's say if you are taking the MEL3E IL, if you sign up for it IL, you can also call in for the 11 o'clock for Kobe's class for MEL3E. Okay, you do not have to be signed up for the radio Zoom classes in order for you to participate. You can also contact your DEC, or you can contact Michelle. She's our WASA counselor. If you have Facebook, she can be contacted through WASA Michelle. That's her Facebook profile. PLAR students who have already registered for this year, you do not need to reapply for term 2B. And if you do not have access to a hard copy of the application form, we do have an online application form. You can go onto this link, and then you can apply. So this is the online application form. It's not an online course, just an application form where you can complete online. For contacting your teacher, so in this case for me, you can call the office. There's a 1-800 number, 667-3703. My extension is 2204. You can also fax to our toll-free number. You can email me at jmercer@nnec.on.ca. You can send me a message through Messenger. My Facebook profile is J Mercer Wasa. My office hours or schedule is available from your DEC, or you can contact me and I'll be more than happy to let you know. You can also call me at home. Once you're ready to submit your key questions, you can have your DEC fax your key questions. You can scan, email it to studentwork@nnec.on.ca. Just make sure that you CC it to the teacher who's marking your work. In this case, you have to CC it to me. So if you're doing PLAR History, Geography, or PLAR Science, you can also use your Notes app to scan, email your work or your key questions. This is very popular with students, sending a picture through Messenger. And another option is you can also drop it off at our WASA office. So there is an outdoor mailbox at the side entrance, the one facing the post office, if you want to send it that way. Okay, other ways for you to get extra help. So again, you can call me anytime you want, or you can message me. If you do message me on Facebook, if it's really late, I will answer you the next day. But if you decide to message me late in the evening because that's when you're doing your work, that's fine. But again, more than likely, I will not be replying till the next morning. So another option for you to get extra help is if you watch the classes on YouTube. So there's my profile for YouTube, same as my WASA Facebook, just to make it easier. So it is J Mercer Wasa, both for Facebook and YouTube. It makes it easier as well to have that all the PLAR packages are the same. So if you have registered through Radio Zoom or IL, then the packages are the same for both. PLAR students may continue where you left off. So if you're having any problems with PLAR Geography or PLAR History or PLAR Science, you can go on YouTube and you can go to the playlist. So you can see the menu, you can have home, videos, playlist, community, about. Go to the playlist. There will be a list of classes, a complete set of classes. Now in this case, PLAR Science, we have already broadcasted that in 1B. So that's in October till February. So there are 16 videos for PLAR Science. When you open the playlist, it will give you a list of all the classes. So in this case, it will say PLAR Science, and then it will give you the lesson number and the key questions within that class. So if you're having any problems with, say, key question 1 or key question 13, look for the key question numbers at the end of the description of that video. Okay, if that doesn't work for you, you can request for a USB of classes. That means that we will download the classes for you, put them on a USB. All you need is a USB port so that you can view these on your laptop or maybe your television. It also works for your Xbox or PlayStation. So this is how it will look like for the 9 weeks that we have for PLAR Science. Weeks 1 and 2, we will work on astronomy. Weeks 3 and 4 will be lesson 2. 5 and 6, weeks 5 and 6, lesson 3 for chemistry. Lesson 4 for physics will be weeks 7 and 8, and then finally we will have lesson 5 and then the culminating for PLAR Science at the end of week 9. You will find in the lessons that there's an evaluation description, which means that in each lesson there are support questions and key questions. Okay, you will be evaluated, or the key questions will be marked for each lesson. So key questions 1 to 80, that's for lessons 1 to 5. So that's the number of key questions you have to complete. At the end of week 9, or if you finish it, it might not take you 9 weeks to do it. Some people take less than that to work on their lessons. Again, you can submit it as you can submit it anytime. Once you complete all 80 key questions successfully, or lessons 1 to 5, I will give you the culminating activity. So in order for you to get the equivalent credit for PLAR Science, you must get 50% or over, okay, to get the equivalent credit. So either your DEC or myself will give you the culminating activity to complete. Then once that's completed, then equivalent credits are granted to students based on individual assessments. Okay, and the culminating is an open book test. So if you received your package, you will see that this is what's on the front page for each lesson. In this case, we're starting with lesson 1. Notice it says lesson 1 and key questions. Key questions are at the end of the lesson book, which means you don't have to send me the lessons. You just send me the key questions that are at the end of your lesson. This page gives you all the numbers that you need. It gives you the WASA Studio. If you want to listen to the classes, you can go on to 91.9 FM, or if you have Bell Express View, you can listen to 972. The Zoom link is provided for you along with the meeting ID and passcode, our toll-free number for the office, our fax number, my email, my Facebook and YouTube. I also have a Google Classroom. 2 ways to access. You can access it using your NNEC Schools account, or you can access it using your personal Gmail account. Notice there are 2 different class codes for the Google Classroom. If your booklet does not say 2023, 2024, maybe you already started working on 2022, 23 version, that's fine. So if you have the 2022, 23, so if you have the previous versions of this lesson, I will accept work that you submitted. Okay, no need to redo it if you've already started using the previous version of this lesson. Again, if you're not sure, all you have to do is contact me, and then I can let you know how to proceed. So here is what you will be required to do for lesson 1. You are required to complete the following key questions successfully so that you can write the PLAR Science culminating activity. So in this case, for lesson 1, you have a total of 26 key questions to complete. And if you look at the total marks for each question, key question 1 is only worth 2 marks. 5, same thing, and 6, those are worth 2 marks. Key question 11 and 12, they're worth 1 mark. So it's not a lot of work that you have to do. Okay, so don't be alarmed when you see that, oh, I have to do 26 key questions. So if you look at the weighting for each question, it's not a lot. As you go through the lesson, you will see items marked as support questions. So the support questions, these help you to practice the skills that's taught throughout this course. The support questions, you do not need to submit them. Okay, they're practice questions. The answers are at the end of the book. Okay, so that you should remember that is at the end of the lesson. For the support questions, the key questions, you know that's the key question because you see a set of keys right in front of that set of questions. So that's the questions that will be used by me to assess your achievement of each lesson's expectations. So you have to answer the key questions for each lesson and submit them to your teacher. Once you start submitting work, you will get a mark sheet just like this one. And this is a good checklist to see how many key questions you've completed, how many key questions you have left, which key question you might have to resubmit or you might have to review. So I will put your name on the student name and then your community, the date. That's my name up there. I'm your teacher. There's your course code. This is PLAR Science. So you can see for each set of lessons, there's a total. So lesson 1 has the most key questions. There are 26. If you look at lesson 4, there are only 8 key questions, and then lesson 5 only has 9. So starting with your, we just looked over pages 1 to 4 already. So page 5, this is where you will see the scientific method, also the learning goals, and the introduction. Page 10, what is astronomy? Page 11 to 15, stars, constellations, galaxies, the Milky Way, the Big Bang, the Hubble Space Telescope, and so on. So we might get as far as page 15 today, we'll see. So let's start on page 5. Let's look at your learning goals. So your learning goals, I can explain the steps of the scientific method. So basically your learning goals is what you will learn. Secondly, I can describe the planets and other heavenly bodies that make up our solar system. And the third learning goal is I will understand the challenges and benefits of human space exploration. Okay, so for sure, we will be going over, I can explain the steps of the scientific method, and I can describe the planets and other heavenly bodies that make up our solar system. Okay, terminology that you will come across. These words, you will see that they are bolded. That means they're darker than the other words or the other words on the page. For example, you might see dependent variable and it will look like that. So you can see it's darker than the rest of the other words. So keep these terms in mind. Scientific investigation, scientific method, independent variable, dependent variable, hypothesis, experiment, observation, analysis, and conclusion. Okay, we will come across these words. This is your lesson book, so you can circle it if you want, you can underline it, you can highlight it. Okay, this booklet is yours. You do not need to return it to me. Okay, let's look at the scientific method. So the word science, notice that it's in quotation mark, comes from the Latin word that means knowledge. So we can think of science as a way to gain knowledge of the world around us. The scientific method is an ongoing process that usually begins with observations about the natural world. So people are naturally curious, and we have always had lots of questions about the things, either things that we see or things that we hear in the world around us. So often people come up with ideas. They also come up with theories or hypotheses about why things are the way they are. So when you look at the scientific method on page 5, some of the scientific investigations may skip one or two of these steps. So right now it's showing you that the first one is question, second one is hypothesis, third one is experiment, fourth is observation, fifth is analysis, and the sixth step is conclusion. Okay, so sometimes you might see more steps, or maybe one or two of these steps will be skipped. And other scientists may follow these steps in a different order. And steps like observation and analysis, these might be repeated over and over. Okay, so if you look at the scientific method, question, ask a question and then research your topic. Hypothesis, what's your best guess? Procedure, write very specific directions of your experiment. Experiment, observe closely and then record data. Then data analysis, organize and evaluate your data. And then conclusion, what did you find and was your hypothesis correct? So we're going to look at each of these steps. Okay, and before we do that, here's an example of a problem using these steps. So in this case, this person has a problem, and his problem is that his car won't start. So how would he use the scientific method to solve the problem? Well, first of all, he can write down the problem or say his problem, my car won't start, and obviously he wants it to start. Okay, so the problem is his car won't start. So the hypothesis is if I jump start, also another way to say that is boost my car, it will start. Okay, so he's thinking that if I do this, then this will happen. So if I boost my car, it will start. Okay, this is hypothesis. Materials, well, what does he need so that he can start his car? Well, he needs a car with a good battery. So he's going to need a friend or someone with a good battery. He will also need jumper cables, instructions to jumpstart his car properly so that he doesn't damage either vehicle's battery or worse, get injured in the process. Okay, so those are the materials, so things that he needs to solve his problem. Experiment. So, first he's going to call his friend Bob to come over to his place with his car. He will park his car nose to nose with his car without the two vehicles touching, but close enough that the jumper cables will reach. Okay, he will turn off the engine in Bob's vehicle, raise the hoods of both vehicles, and locate the two batteries. He will then connect the cables to the battery terminals, and notice, as per our instruction booklet, the start my engine. Okay, so he's connecting the cables to the battery terminals to start his vehicle. Okay, results. The car started on the first try. So his conclusion, when I boosted my car, it started. Was his hypothesis correct? Yes. He said if I boost my car, it will start. And the conclusion after he's done the materials, the experiment, so his conclusion worked, it did start. So what happens if his car still won't start? Then that means that his hypothesis, so if I boost my car, it will start, that was not supported. Okay, if it didn't work. But in this case, he was lucky. His car started, which means that his hypothesis is supported. Okay, so we'll break each step down. So we are now looking at each step of the scientific method. So the first one is question. So a scientific question is often about cause and effect relationships. So these questions are often stated in the form, what will be the effects on one thing if we change another thing? So if I boost my car, then it will start. Okay, there are two main variables in an experiment, and these are independent and dependent variables. So an independent variable is the variable that is changed or controlled. So that's what can be changed or controlled in a scientific experiment to test the effects on the dependent variable. Now the dependent variable is the variable that's being tested and measured in a scientific experiment. So if you look at the two plants this on the screen, one plant is labeled A and the other plant is labeled B. So what are we trying to figure out here? In this case, the liquid used to water each plant. Okay, so the independent variable, the one thing you change, you limit to only one in an experiment. So the independent variable in this case is the liquid that's used to water each plant. So this plant, plant A, okay, pop is being used to water that plant, and then in plant B you have juice that's being used. Okay, so the independent variable is what you can change. So either you use pop or juice. The dependent variable is the change that happens because of the independent variable. So let's look at plant A and plant B. So one was watered with pop, the other one was watered with juice. The dependent variable could be the height or the health of the plant. So in this case, there wasn't a whole lot of difference between plant A and plant B. Okay, whether it was watered with pop or juice, based on the picture. Okay, so remember the independent variable is the variable that you can change, and then the dependent is the change that happens because of the independent variable. Okay, the next step is hypothesis. Okay, so a hypothesis is a possible explanation of why one variable affects another. It's an educated guess. Okay, and it can be based on something that you already know or something that you may have experienced. Maybe your car won't start, and maybe you already know that, hey, the last time that I put gas in my car was maybe 2 weeks ago. So, and if it's not starting, you might hypothesize, if I put gas in my car, it will start. Okay, so that's your hypothesis. So this hypothesis is then tested to gather evidence to prove or disprove your educated guess. So you're looking to a suggested solution to the problem. It has to be testable, sometimes written as if or then statements. So if I put gas in my car, then it will start. And it also predicts an outcome. So your prediction is it will start if I put gas in my car. Other scientific hypothesis examples, plants require liquid water to survive. Okay, again, this is testable because this would be disproven if you find a plant that doesn't need water. Here's another one. Classrooms are noisier when the teacher has left the room. Okay, can you test that? Sure you can. Okay, you can have a classroom, and then when the teacher leaves, you can test to see if you find that, yes, the classrooms are noisier because the teacher has left the room. Hypothesis, another example, objects made of metal will sink in water. Okay, is that testable? Yes, you can find different objects that are made of metal and see if it sinks in water. Okay, experiment. So the experiment consists of a list of materials that you will need, and you will also need a procedure. So remember, with trying to start or boost his car, the materials he needed was a car with the good battery, so he got that from his friend. He also needed instructions to boost the car, and he also needed jumper cables. Okay, so those are the materials for this person when he was trying to start or boost his car. So the procedure is a set of detailed steps that describe how you will conduct your experiment. It is important to be able to write an experimental procedure clearly, concisely, and accurately. That means that anyone who is interested in your experiment should be able to understand how it was performed so that it can be repeated. Okay, straightforward. Your experiment is a list of materials, everything and anything that you need to carry it out, and then you also need the procedure, so that if anyone were to try and conduct your experiment, they can do it. Okay, it needs to be accurate. Okay, next is observation. So as the experiment is conducted, so as you're doing your experiment, it's very important that you note down the results. In any experiment, it is necessary to conduct several trials. So sometimes you might need to do it more than once, even more than twice, or even more than 3 times. Because you're trying to make sure that the results are consistent. So as you carry out your experiment, you will need to record any observations that you make. So depending on the experiment, so if you're following along in your book, you're on page 8. Okay, so on the very first page, so depending on the experiment, your data may take the form of numbers, or it might say yes or no, it might say present or absent, or other observations. So here you can see a chart. It says, does the amount of light a plant get affect how quickly it grows? So for this chart, you have 3 plants. You have plant A, plant B, and plant C. Notice plant A is blue, plant B is red, and plant C, okay, is in green. So day 1, all the plants, okay, are at 1 inch. So on the left hand side is the height, okay, of the plant, and then on the bottom one is number of days, okay, that the plant receives light. So day 1, it's the same. Day 2, it's the same. Notice on day 6, plant B was moved into the closet, and then plant C was moved onto the window. Okay, so you notice now B and C. So what did you notice by day 10? The one that was moved to the window, so plant C, was at 4.5 inches taller, or that's the height of it, final height by day 10, whereas plant B by day 10, it started at 1 inch. It actually got shorter, or probably wilted. It's at 0.5. So here's a picture of the plants. The more light there is, the better the plant will grow. So looking at the chart, we know exactly which one is plant C. Okay, plant B is this one here at the end, and the control is at plant A. So graphs and charts make it easier to see patterns and trends in your observations. Also, a graph is an easy way to see whether a relationship or pattern exists between two or more variables. So in this case, we know that plant B that was moved into the closet, okay, it's not, or it didn't grow very well because it wasn't getting enough light. It also allows you to see what the relationship is so it can be accurately described in words or mathematics. Graphs will also help you determine whether the observations support your hypothesis. So your hypothesis might say the amount of light a plant gets affects how quickly it grows. Or you might say if a plant gets more light, it will grow better. And then you can see right on the graph or the chart that your hypothesis is correct or supported. Because notice how plant C that's been moved onto the windowsill, which gets more light, that plant continued to grow taller. Okay, analysis. So after conducting the experiment and recording your observations, you will need to analyze all the data that you received and use it to draw a conclusion regarding the strength of the hypothesis. So if the data proves the hypothesis is correct, the original question is answered. So you can record your data, could either be a picture, a table, or a chart, and then basically you're thinking about it. On the other hand, if the data disproves the hypothesis, the scientific inquiry continues by doing research to form a new hypothesis and then conducting an experiment to test it. Okay, so if it, for example, that very first hypothesis, we said, my car won't start, I want it to start, and his hypothesis was if I jump start or boost my car, it will start. So let's say it wouldn't start, even though he got a battery, he had the jumper cables, he found a friend who had the car, they tried to boost it and it didn't start. That means the hypothesis was not supported. So my car still won't start. He then needs to try again. So maybe it wasn't the battery. Maybe this time it's gas. He needed gas. So then his hypothesis will change. If I put gas in my car, it will start. So then he has to test that. Okay, conclusion. You state whether your prediction was confirmed or not and try to explain your results. Okay, so this person is saying my hypothesis is supported, my plants grew better in light. So remember that one was the hypothesis that light affects the growth of plants. So work in science does not end with a single experiment. Investigations can be repeated many times. So the following guidelines may help you suggest further experiments. Okay, so you may suggest repeating the experiment using a new or improved design that fixes any flaws that were noted. You might try to use better equipment to make more precise measurements. A revised procedure to collect additional evidence, or better skills in using the equipment. Okay, maybe you weren't quite sure how to use the equipment, so that might affect the experiment. Review the hypothesis and look for new ways to test it or suggest a new hypothesis. Okay, let's try to do some key questions. Let's try doing key questions 1 to 4. So again, your key questions are at the end of the lesson. Please note that you do not need internet. That means you don't need internet or Wi-Fi, so you don't need to do a search. Okay, no searching, because you don't need to do that to complete any of the key questions. Okay, they're all in your book. So again, these are the key questions. We are going to look at doing key questions 1 to 4. Notice key question 2 is weighted at 18 marks, and you will see why. Okay, also for the key questions, for some of you that have had the previous versions, you didn't have any lines given to you. I just gave you the key questions and I didn't provide any spaces for them. So the newer ones, it does have spaces for you to write your answer down. If you still don't want to write it there, you don't need to rewrite the question. So the first question says, what is a scientific investigation? You don't need to write that. You can just label it as 1 and then answer the question, what is a scientific investigation? Okay, but it's up to you. If you prefer to use the space that I have provided for you, you can do that. If you need additional space, you can use line paper, okay, if needed. Okay, you will see that there are 3 types of questions, okay, in PLAR Science. The first type is a hand question, and the hand question is exactly that, because it's a question and the answer can be found in the text. You can put your hand right on the answer, or your finger. Okay, so remember that. So you can ask yourself, is it a hand question? Well, if you can put your hand right on the answer in the text, then that means it is a hand question. So the hand questions, they are literal level questioning. Answers can be found directly in the text, and you can put your hand or finger on the answer. So in this case, what is a scientific investigation? That is a hand question, is an example of it. So scientific investigation is also a way of learning about the world by observing things, asking questions, proposing answers, and testing those answers. Okay, that's the answer to key question 1. It's a hand question. Okay, the other type of questions you will see is it a head question? So in this case, are there clues in the text? Even if the questions isn't answered directly, then you need to use those clues along with your own background knowledge, so knowledge that you already know about it, to infer or to make an educated guess about the answer. So for head questions, clues in the text but the answer is directly not stated, may be referred to as inferring or predicting. So for example, some people, this is key question 24, some people believe that society should build places for people to live in space. Why might people want society to do this? Okay, so that's the question. In your text, it says, in 1976, 2 Viking spacecraft landed on Mars. One of their main objectives was to check the Martian surface for life. They found many of the necessary ingredients for life, but no evidence that there was actually anything alive on the planet. So you might infer or predict that, society might want to build places for people to live in space, because Mars, for example, seems to have what we need to live there. Or you might say, some people might believe that society should build places for people to live in space. It might be because it's overcrowded. It's getting overcrowded on Earth. Okay, so you're predicting. Number 3, is it a hard question? So think about, are there no clues in the text? So you have to speculate on the answer based on your own background knowledge or give your opinion. So a hard question is an opinion-based question. It offers no clues in the text to the correct answer. Answers may be speculated based on background knowledge or feelings, often opinions or personal responses. Here's an example of a hard question. In your opinion, is human exploration of Mars a good idea? Why or why not? Okay, so that's your opinion. You might say, yes, I think that human exploration of Mars is a good idea. Or you might say, no, I do not think human exploration of Mars is a good idea. And then you have to provide your reason. So why do you think that it's a good idea, or why not? Okay, so we answered key question 1, what is scientific investigation? So remember, you don't have to rewrite the question. Scientific investigation, and then write your response. Key question 2, identify and explain the 6 stages of the scientific method. So we talked about the 6 stages, and in this case, so there are 6. You get a mark just for naming each stage, and then 2 marks for your explanation. So the first stage is question, second stage is hypothesis, okay, third step is experiment. So again, you don't need to do a search on the internet, you can find this in your book, okay, and so on. So complete 4, 5, and 6. Brief explanation. Very brief, just enough so that you can show to me that you're understanding what question is. So question could be, you must be able to test an idea. Okay, and answer the question. So just a brief explanation. Okay, key question 3. Explain 2 ways that graphs and charts can help a scientist record their observations. So it says 2 ways. So 2 ways. Okay, graphs Okay, and charts. Dot, dot, dot can help scientists record their observations. So again, look in your book and see what are two ways that graphs and charts. So make sure that you're looking at graphs and charts. You can read this on page 8. It's under the heading Observation. Okay, and then finally, how can experiments be sabotage? And why would this be a bad thing? Again, this question, okay, this key question is in your book and under observation, okay, page 8. And you will find this word sabotage on that page. So if you see that word, then you know that you're on the right track. Okay, we're going to stop here, and we will continue with lesson 1 tomorrow. We'll pick up and start looking at what is astronomy. Okay, thanks for joining me. Have a good evening. Miigwech.